all. Today we'll be seeing about the inverse trigonometric functions, important concepts and formulas. This is a chapter of class 12. So firstly, let's see about the inverse trigonometric functions. First of all, we have studied about trigonometric functions in class 12. So, one important function is sine theta is equal to x. So, in an inverse trigonometric function, we give a value for theta which is sine inverse of x. Here, we bring the value of sine towards the right hand side and we give this as a value to theta. So, we get theta is equal to sine inverse of x. For example, in our trigonometric function, sine pi by 6 is equal to 1 by 2. So, similarly, in our inverse trigonometric function, we get a value pi by 6 is equal to sine inverse of 1 by 2. Now, we know that the value of theta should lie between an interval, and this interval is called as principal value branch or range. The value of sine inverse of x lies in the range minus pi by 2 to pi by 2. So if we take a value of sine inverse of x, it lies between the interval minus pi by 2, that is minus 90 degree, and pi by 2, that is plus 90 degree. So let's see about the domain and range of various functions. First of all, we have sine inverse of x. The domain is minus 1 to 1, that is minus 1 and 1 are included, and the range is minus pi by 2 to pi by 2. This value of minus 1 and 1 are the values of x, and this value of minus pi by 2 and pi by 2 are the values of theta. So when we go to cos inverse of x, similarly we have close bracket minus 1 to 1, where minus 1 and 1 are included, and the range is 0 to pi. When we go to tan inverse of x, we have all the set of real numbers, that is represented by r over here, and the range is minus pi by 2 to pi by 2. Now, next is cot inverse of x. It also has the same value as tan, which is r, that is set of all real numbers, and the range is 0 to pi. Next, we go to the cosec inverse x. Here, we have a range minus infinity to minus 1 union 1 to infinity. This indicates that minus infinity is not included and minus 1 is included. It includes a set of value from minus infinity to minus 1 and 1 to infinity. 0 won't be included over here. And the range is minus pi by 2 to pi by 2 minus set of 0, that is 0 won't be there. All the other numbers in the range of minus pi by 2 to pi by 2 will be there. So next is sec inverse of x, which has domain in the range minus infinity to minus 1 union 1 to infinity, the same manner as cosec inverse of x. We have the range as 0 to pi minus pi by 2. Here minus pi by 2 won't be included, all the other value will be included. So next, let us look at the different properties. First of all, sine inverse of x is equal to minus sine inverse of x, and cos inverse of x is equal to pi minus cos inverse of x. Tan inverse of x is equal to minus tan inverse of x, and cot inverse of x is equal to pi minus cot inverse of x. Cosec inverse of x is equal to minus cosec inverse of x, and sec inverse of x is equal to pi minus sec inverse of x. So we can see that the value of sine inverse of x, tan inverse of x, and cosec inverse of x have minus value, and the value of cosec inverse of x and cot inverse of x and sec inverse of x have a pi minus cos inverse of x. So the next is, when we write cosec inverse of x, it is not equal to 1 minus sine inverse of x, but it is equal to sine inverse of 1 by x. This is a property which we should remember. Similarly, for sec inverse x, it is equal to cos inverse of 1 by x. This point should be noted. The same way, for cot inverse of x, tan inverse of x is equal to 1 by x, which can also be represented by pi minus tan inverse of x. Now let's look at the next set of properties. Sine inverse of sine theta will be equal to theta, where theta lies in the interval minus pi by 2 to pi by 2. Cos inverse of cos theta is equal to theta, where theta lies in the interval 0 to pi. This is the range of sine inverse, that is just like we have looked in the previous slides, and this is the range of 0 to pi, which is the range of cos inverse of x. So when we look at tan inverse of tan theta, it is also equal to theta, which is theta belongs to minus pi by 2 to pi by 2. And when we look at cosec inverse of cosec theta, is also equal to theta, where theta belongs to the interval minus pi by 2 to pi by 2 minus set of 0. Next is sec inverse of sec theta is equal to theta, where theta belongs to 0 to pi minus offset pi by 2. And next is cot inverse of cot theta is equal to theta, where theta belongs to the range 0 to pi. So we have seen in all these cases we have sine inverse of sine theta. Any inverse of the same value with theta, it will be equal to theta in all the conditions, just the range changes. So the next set of properties is sine inverse of x plus cos inverse of x will be equal to pi by 2. That is, adding this value, that is, we get an angle over here for theta value over here, and this theta value, the angles when they are added, we get pi by 2. Similarly, when we add tan inverse of x plus cot inverse of x, again we get pi by 2. Cosec inverse x plus sec inverse x is also equal to pi by 2. So these are the pairs that should be added to get pi by 2. So sine inverse of x is equal to cos inverse of x root of 1 plus x square. How do you get this equation? We know that sine square theta plus cos square theta will be equal to 1. When we substitute that value over here, we get sine inverse of x. That is, that square becomes root over here, cos inverse of 1 plus x square. That's how we get this equation, and we get this equation too. So the next set of properties is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus x square. To remember these equations, you just have to see that when you get a plus over here, you give plus in the numerator. When you have a minus over here, you give a plus to the minus to the numerator, and you put the opposite side in the denominator. This is a simple method to remember this. So 2 tan inverse of x is equal to sine inverse of 2x divided by 1 plus x square. 2 tan inverse of x is also equal to cos inverse of 1 minus x square divided by 1 plus x square. We also have seen a formula in trigonometry. Sin 3x is equal to 3 sin x minus 4 sin cube x. And we can put the inverse of this function. That is 3 sin inverse of x is equal to sin inverse of 3x minus 4x cube. This is derived from this formula. And we also known as 3 cos inverse of x is equal to cos inverse of 4x cube minus 3x, where cos 3x is equal to 4 cos cube x minus 3 cos x. So thank you. If you like the video, like, share and subscribe for more such videos.